Good morning, boys. Today we are meeting with you with a new chapter, electrochemistry, just for the purpose of revision, as well as some questions will be given, as I have already told. Okay, you have to solve the questions and in the same copy, which you have already done. So this is electrochemistry part 1, some question related to cell reaction, some questions related to electrochemical cell. You know that electrochemical cell is a device which converts chemical energy of the reaction into electrical energy. Okay, and there is one more type of cell, that is electrolytic cell. Electrolytic cell is a different thing. It's a device which converts the chemical electrical energy into a chemical energy, just opposite to it. In this case, you remember that electrochemical cell, electric current is produced, and in electrolytic cell, electric current is consumed. This is the basic difference between electrochemical cell and electrolytic cell. Electrolytic cells are mainly used for the purpose of electrolysis, and there you will see the Faraday's law of electrolysis. Okay, I am here today for discussing about electrochemical cells. Electrochemical cells, the main design, it is given by John Daniel, which is named as Daniel cell. Electrochemical cell, the particular designing of the cell is made by John Daniel, and so they are known as Daniel cells. And Daniel cells, voltaic cells, galvanic cells, generally boys confuse. These are all same things, okay? Daniel cell, what is Daniel cell? That design is known as Daniel cell, and it is voltaic cell or galvanic cell when the cell is working under standard condition. We say it is voltaic cell, we say it is galvanic cell. So there is no other any difference. Now see, here is a cell reaction given. Zinc dipped in nickel solutions, nickel sulfate, nickel chloride, whatever be it, electrolyte of nickel solution, aqueous solution, and this reaction is going on as it is shown here. These are the values given. Electrode potential, you know electrode potential, the potential that is developed between the electrode and its surrounding solution. This electrode potential, these are not standard, electrode potentials are given. From the notation it is clear that this is oxidation potential given and this is reduction potential given. Here you see the reduction Ni2 plus 2 Ni, it is reduction, so it is reduction potential, and this one is oxidation, so it is oxidation potential. So you can work any, it can be given in any term, either in reduction potential or oxidation potential. You know how to change it. As you know that reduction potential and oxidation potential for the same species, their magnitudes are same. Oxidation potential equals to reduction potential, only the sign will differ. You can say that oxidation potential equals to negative of reduction potential, or you can say reduction potential equals to negative of oxidation potential for the same couple. Remember it, for the same couple. Now the question is given, is it feasible or not? This reaction is feasible or not, means reaction is spontaneous or not. You know the reason for spontaneity. Reason for spontaneity is delta G, that should be less than 0, or you can say that E cell should be greater than 0. So any condition you can apply, delta G less than 0, the reaction is spontaneous, or E cell is greater than 0, the reaction is spontaneous, means feasible. This term is used in the book. So you have to find E cell for the reaction, and then you have to write whether it is feasible or not. If it is feasible, then you find the electrical work done by the cell. Electrical work done by the cell, You know that electrical work, what is electrical work done by the cell? Electrical work equals to uh, charge multiplied by potential distance, charge multiplied by EMF of the cell, total charge multiplied by the EMF of the cell. So work electrical, this is equal to NFE, cell. We write E cell. EMF of the cell is written as E cell. So electrical work equals to NFE cell. Okay, remember it. Electrical work equals to NFE cell. You have to find the electrical work. It is done by the cell. So remember, any work done by the cell or any work done on the cell, these are signs are different. You will manage the sign. So this is electrical work. You have to find NF into E cell. Okay. Now question number 2, you see SRP of X is given. SRP means standard reduction potential of X is given, Y is given, Z is given. These are the three values given, SRP values are given. You have to arrange the elements X, Y, Z in their increasing order of reducing power. You have to arrange the elements in their increasing order of reducing power. This is question number 2. Question number 3, the standard reduction potential of this one is given, standard reduction potential of this one is given, standard reduction potential of this one is given, and standard reduction potential of this one is given. Which one is the strongest oxidizing agent? You have to find out of these four SRPs, you have to compare and you have to find which one is the strongest oxidizing agent. This is question number 3. Question number 4, find the RP, reduction potential and oxidation potential of this couple. Concentration of the electrolyte is given at 25 degrees centigrade. Standard reduction potential is supplied to you. So this is half cell, you know. It is clear that you have to find the reduction potential and oxidation potential of this half cell. So you have to use Nernst equation. Nernst equation, you have to use it, Nernst equation. You know for a half cell or for a complete cell, how to write the Nernst equation. Nernst equation is E cell equals to E naught cell, that is EMN plus slash M. This is equal to E naught M N plus slash M minus 0.059 by N log product by reactant. This is Nernst equation in a simple form. Nernst equation, E cell equals to E naught cell minus 0.059 by N log product by reactant. So you have to write this half cell reaction and you have to find the reduction potential. This one, this value is given, this value is given. You have to find the value of N and the concentration of the product by concentration of the reactants as it is given here. You have to find the reduction potential as well as oxidation potential. So it is clear that reduction potential and oxidation potential, their magnitudes will be same, only they will differ in their sign. Just you do it. Okay, this is the first part of the assignment. Now I am giving you some more questions and you have to note down the questions and you have to answer them very clearly. These type of questions generally concept based questions and usually come in the examination. Okay boys, now come to the second part. Second part you will, second part of the questions will be written first, then I will discuss it again. So this is find the EMF of the cell, Cr oblique Cr3 plus, concentration is given, salt bridge Fe2 plus oblique Fe, concentration is given, E0 values are provided, so you have to use Nernst equation, you know, EMF of the cell equals to standard EMF, you have to find the standard EMF of the cell, standard EMF of the cell equals to E cathode minus E anode, then using this equation minus 0.059 by n log product concentration by reactant concentration. Okay, first you will convert this cell notation to cell reaction. Stoichiometries have also some uses, as you know. Directly EMF E naught of the cell is given. See, E naught of the cell is given directly 0.236 volt. 0.236 volt. Find the value of delta G naught and K. K means equilibrium constant. This is question number 6. You know that E naught cell and delta G naught, here the relation is known to you that delta G naught equals to minus NF E naught cell. Delta G naught equals to minus NF E naught cell. So E naught cell is given number of moles of electrons transferred that you will come to know by balancing the reaction. Cell reaction is given. Number of electrons, number of moles of electrons transferred during oxidation and reduction that can be known by balancing the reaction. So once delta G naught is known, you can find out the value of K because you know the relation between equilibrium constant and delta G naught. Okay, delta G naught equals to, what is the relation? Delta G naught equals to 2.303 RT log K. Delta G naught equals to 2.303 RT log K. So this relation for equilibrium constant, finding the value of equilibrium constant. So these two things you will find it. Now I am giving you a questions from concentration, cell concentration. This is the last question, number 7, concentration cell. Concentration cell. So this is concentration cell. The representation is given at 25 degrees centigrade. Concentrations are different as you see. Concentration cell, two half cells, same electrodes, same electrolyte having different concentration. And another point related to it is that E naught of such cell, E naught of such cell is equal to 0. Remember it, E naught of such cell is equal to 0. So you have to find out the EMF of this cell, concentration cell. So these 7 questions you will do as home assignment, as your homework. And next class, we shall again discuss some in detail the next part of this chapter. Okay, boys, till then, you should not waste time. You should write the questions, note down the questions in your copy. Same copy must be used as same teacher assignment is given. So same copy must be used. Only the headings you will write electrochemistry part 1. Then you will solve these questions. And in this way, you go on your preparation, carry on your preparation. All these homework assignment will have credit as I have discussed in the class with you. Okay, boys, thank you. Thank you.